Assalamualaikum warahmatullahi wabarakatuh.
We are from Group 1. My name is Agung Erdiansah.
Ikhwan dan Hiyahara.
My name is Azizah Rahayu.
My name is Ishmah Ulyadinah.
Here we will do light refraction practice.
The aims of this practice is prove Snell's law of reflection about the refraction of light. What is the theory of light refracting matter? Refraction of light means the bending of the direction of propagation of light as it passes through the boundary of two transparent medium with different refractive indices. In Snell's first law, it reads the incident ray, refracted ray, and the normal line lie in one plane, while Snell's second law reads if the ray comes from a tenuous medium to a dense medium, for example from air to water or from air to glass, then the ray is bent closer to the normal. If, on the other hand, light comes from a dense medium to a loose medium, for example, from water to air, then the ray is bent away from the normal. An example of the application of Snell's law, for example, is light traveling from medium 1 with velocity and angle to incidence I towards medium 2, when in medium 2 the speed of light changes to v and the light is refracted with an angle of refraction r. The direction of propagation of light can be bent because it passes through two different mediums. Remember, every medium has a different refractive index and is specific. Refractive index is a quantity that shows the ratio of the speed of light in a vacuum and in a medium. The bending of light is caused by the speed of light from air to a different medium, such as water. One the characteristic of light is that it can travel in a straight line. However, if light passes through two medium with different indices, the light will be bent.
Apparatus of this practicum is
Water,
Glass.
Straw,
coin
and
and
reading
row.
Procedure: the first experiment. Put the water in a glass. Put the arrow behind the glass, fill it with water. Raise and lower arrow. See the difference.
Next, the second experiment. Here we will see the change of the coin that is placed under the glass. Okay, the first is put coin under the glass. The next, slowly pour water in the glass and watch what's happened.
Procedure: the third experiment. Put water in a glass. Take a coin and put half a coin in the water. And see the difference.
Procedure last experiment. Put water into the glass. Bukannya pure. Next, put the pipette atau put a straw into the glass. Next, show the difference into the glass.
aqua glass can be said to be transparent so that the two arrows still point to the left. By filling it with water, the aqua glass acts like a convex lens. The center is thicker than the edges, and produces an inverted image when we view it at a distance outside the focal point. For standard drinking glasses, the focal point distance is short enough that makes it easier to experiment.
On the second try, it turns out that the coin seems to disappear. Why do coins disappear when viewed from the side? We can only see objects when there is light hitting them. Glass is a clear object, so it passes almost all of the light it receives. Hence, the coin is visible. Water is also a clear object, but why are coins invisible? This proves that the light that comes and passes through the wall of the glass filled with water changes direction or diffraction. As a result, light no longer falls to the bottom of the glass, so that the coin becomes invisible.
Why do some coins get bigger when put in water? This occurs due to refraction of light. Refraction occurs when light enters a different medium, in this case, light passes from air to water. The conclusion this practicum is Snell's law shows the incident ray, the normal line, and the refracted ray are located and on a plane, and the question of the sign of the angle of incidence with the sign of the angle bias is a fixed number and is called the index of refraction. Refraction of light occurs when light passes through a media with different optical density.